Hello everyone, thank you for being here for our talk, Making a Mountain Out of a Module. My name's Joe, and I'm here with my friend Ataul, behind me there. And this talks about modularization, dynamic feature modules, Android libraries, and the kind of things we come across in our projects and how they all come together. We wanted to learn how to approach these topics, so we built a small sample app for ourselves to work on as a little side project, and this talk's kind of a chance for us to share our learnings and what we did in this process. So to tell you a bit more about this project, I'm going to pass you over to Ataul.
Hey everyone. So we made a client for a service called Letterboxd, which is a film tracker. It's similar to Goodreads, so if you use that, you'll understand what it is as a concept, but instead of books, it's for movies. And our client is very simple, since it's only got 3 screens and 2 of them look basically identical. Let's start with a quick tour, and we'll have a look at what a single module approach might look like for this app. First up, we've got the feed, which is a list of movies. So when the user taps on one of these items, we go to the film detail, which shows more information about the movie, and as well, it shows some information about the cast. When the user taps on one of the cast members, we'll show the actor detail, and this is where we're going to show some information about the actor, as well as all the movies that that actor stars in. In a single module app, that'd all be in the application module, these 3 screens. We could use packages to keep our features and our screens separate, but the separation would be mostly superficial, especially if we're using Kotlin, which doesn't support package scope visibility. As your app grows and your team scales, you might wish there was more friction than using packages to reduce coupling between different parts of your system, because it's easier to work in parallel with other people if there's explicit contracts for public APIs. The other major consideration is build time. So with a single module app, every code change means recompiling the entire app. So what could this look like as a multi-module project? So we'll still have our app module with the Android application plugin. But now, instead of using packages to separate our codes, we can pull them out into separate modules using the Android library plugin. So now, we can use Kotlin's internal modifier to keep code isolated to one module. We can make isolated code changes in parallel with other members of our team, which is great for people in larger companies. And also, only that module and the ones that depend on it need to be recompiled whenever a change is made. So it's likely in a real-world app, you'll still need some sort of base module, something that's shared between the different parts of your application. So here, for example, we can define an interface for a navigator in the core or the base. And the feature modules that depend on this interface, so it can use the navigator, but the implementation for it is provided by the app, since that's the only module that knows about all the different screens. So we've seen a single module app. We've looked at one approach that we might take for multi-module apps. What about dynamic feature modules? So these are the benefits that are listed on developer.android.com. The first 2 we can do already with the multi-module approaches. The last one is where the dynamic feature modules comes into play. So modules which are dynamic can be provided in 4 different ways. So the first one, at install time. This is what we're used to normally. The second one, modules can be provided on demand, so when it's specifically needed. Third one, conditionally. So this is when a module might be downloaded based on particular hardware requirements or minimum API levels. And finally, instantly. So you can have instant apps where dynamic feature modules are provided without an explicit install from the user. And that sounds cool, but this flexibility comes at a cost. To support dynamic features, your app needs to be structured differently. You need a base APK, so this is the one that we use the Android application plugin for. And this needs to have your launcher activity, so the one that the user sees when they click on your app icon in the launcher. So we can still pull that launcher activity out into a library module, so it's the same as we had before. But the features we want to be dynamic can't be dependencies of app anymore. Instead, they'll have app as their dependency, so they're building on this base APK. And app doesn't know about the classes or the resources in dynamic feature modules. And this comes with its own set of considerations. But first, let's have a quick look at clean architecture.
Cool. So when we thought about building this project, we wanted to approach it with clean architecture in mind. Not only is it something we both use in our own projects, both at work and in our side projects, but it's something that we see used in the community and talked about quite a lot. For those who may not be familiar with clean architecture, the approach allows us to craft our application in a way that makes it have a clear separation of concerns throughout the different layers, which makes our code base a lot more maintainable and easy to test. And clean architecture itself isn't anything new. It's been around for years and is quite established in the community. But when it comes to modularization, especially feature modularization, there's a couple of differences that we had to start thinking about, because we have, for example, in our projects that may use clean architecture, we have our modules that separate our layers. So it may have a UI module, a domain module, a data module. And we started asking questions, well, if we have feature modularization, what will this look like for that? How do we split modules up in that way? So when it comes to clean architecture, we can view our application as a collection of different layers. As you can see on this diagram here, we have 4 different layers of the system separation. With the innermost layer, we have our enterprise business rules. So this is where the core business rules of our enterprise live. So these are things such as maybe data models and properties that define the way in which our business operates. So in the case of this movie app, we could say a movie or an actor is a core part of our business rule. We then also have application business rules. So these are similar, except they are confined to the scope of our current application. So whilst something like the movie model or the actor model will be something that span globally across our application, something from the application side, business rule side of things, won't span quite so wide. We then have the interface adapters layer. So this is where things such as presenters or model mappers and other things to do such as data repositories will live. And then finally, the outermost layer is the frameworks and drivers. So this is the things that's kind of anything that's framework specific. So like the Android UI toolkit, maybe a database library, networking stack, and so on. For these, we can see that our application becomes a collection of independent layers, each with their own single responsibility that is independent from one another and completely decoupled. So for example, our Android framework-specific things are not directly tied to our presentation logic or our cache logic or so on. And whilst those benefits, such as the framework being independent, may be seen more when it comes to web frameworks, as these are things that are constantly changing, when we come to multi-platform technologies on mobile, this approach becomes quite interesting to us, because things such as the domain and data layers of our application can be reused across different platforms. Now, what keeps these dependencies completely decoupled from each other is the direction of those dependencies. So dependencies only point inwards. So a layer, so if we take the second layer, for example, that layer will only know about the layer inside of it, and it will not know about any of the layers outside of it. So if our presentation logic only knows about the domain interfaces, then the use case, the domain logic in the innermost layer will not know about anything outside of it. So it keeps the implementation details specific to those layers, and the layers inside of it only know about the abstractions. Now, because these are guidelines, not one size fits all. So there's many different things that you could look at clean architecture and think, I don't really need that, or this is kind of overkill for my application. The number of modules may vary, the way we handle data models may look very different, and it's important to look at it as a higher level approach and how we could implement that within our apps ourselves. So one thing that I mentioned previously is that the number of, so we looked at the number of layers that there were, but this doesn't necessarily mean that we're going to have these 4 modules in our application. When it comes to Android, these layers do not represent the modules that we may have in our app. So for example, we have the frameworks and drivers module, which is the outermost layer. This may consist of multiple modules to make up this concept. So for example, we may have a UI module, we may have a cache module, a remote module. These are all things which are directly tied to frameworks. So they sit on the outermost layer of our application. It does not mean that they represent a single layer in the onion diagram. And when it comes to clean architecture, one of the things that we were a bit stumped about at first was the requirement of having data models which are represented inside each layer of our application. So When you have an enterprise business rule, such as a data model like the movie, as that movie moves through the layers of applications, the guideline is to have a model representation in each of those layers. So that means that there's no tight coupling between those models. So as we go from the domain layer to the presentation layer to the UI layer, there's meant to be a single representation of that model defined in each of those layers. Whilst that keeps our code completely decoupled and it kind of keeps things tidy, it gets a bit tedious. So we have to map between these models, we have to update these models when we change things in our business. And to be honest, we found that a lot of the time, these models weren't actually changing. We were just doing stuff for the sake of it, and they were kind of staying the same. So for this reason, we decided to get rid of this overkill and remove this kind of tedious effect. So sometimes in the project, we skipped this mapping and we only had data models which were referenced from one model and kind of skipped past and reused that data model in different places. So with multi-module applications, with clean architecture especially, we originally looked at a kind of structure that's quite commonly used in the community when looking at clean architecture projects. So we have a collection of different modules which split up the layers of our application. So we may have a UI module, we may have a domain module, a data module, and a remote and cache module that splits these responsibilities up into different separations. When that happens, when it comes to things like libraries and dynamic feature modules, what happens to all those different responsibilities to do with cache, to do with data, to do with the domain layer for all of those features? Are we just going to lump all of those different feature classes into these modules that we have in application? And that could cause things to become extremely bloated for us. We could have in our domain module, we could have all these different use cases for all these different features, and all these implementations begin to become aware of one another, and we have a complete break of that responsibility separation. For this reason, we decided to look at taking each feature module and providing with its own module that had the implementations that it only needed to know about. So our film detail and our actor detail features are features in our feature modules in our applications. They're dynamic feature modules. So each one of these has its own module which defines the things that are specific to that feature. So we have a film detail domain module which defines the use cases and the data models for that feature. We then have a data module and a remote module. And that remote module is responsible for handling any networking that is specific to the film detail tasks. We then also have the same kind of setup for the actor detail, again, going through that domain, data, and remote setup. Whilst at first we felt this was giving us a lot of models, we realized that it really helped us to create a clear separation of concerns, and it made our modules really focused and confined to the feature that they were created for. And this also meant that none of our features knew about any other features in the application. They were just responsible for the things that they're created for. And this goes back to some of the advantages that Ataul previously mentioned. We have build times, we have a clear focus of ownership as well in our teams and the things that we're working on. In some cases, though, we found that there was becoming a lot of shared logic and a lot of shared data models that were happening, that were causing a lot of duplication of code in our project. So within the film detail domain module and also the actor detail domain module, we had some data models that were duplicated. We had some logic which were also being duplicated. So for this reason, we decided to explore creating these base modules which are feature domain modules would be dependent on. So this base domain module allowed us to share stuff between our layer modules, and that could be reused throughout the application. And with these modules that are defined here, so the film detail and the actor detail are features. So whilst we have these layers set up, they also needed to perform navigation between them. And as the film detail launches the actor detail module, and navigation became another topic that we needed to think about.
So in a single module project, it's pretty easy to navigate because the classes can reference each other. You could do some work, for example, to reduce the potential coupling by introducing a single navigator class. But still, everything is available to everything in the same module, so there's no blockers from navigation. In a dynamic feature world, though, how are you supposed to navigate when activities from different modules don't know about each other? Well, you might think maybe we can use deep links. So the receiving activity just needs to declare an intent filter for that URI, and we can launch intents from anywhere starting from Android 1. And this sounds perfect, except it doesn't really work. Instead, you have to navigate with the class name. These are resolved at runtime. what we did was we pulled all of these functions into a single module which anyone can access. We could spend some time to separate these into different interfaces in the navigation module. So instead of having one file with loads of global functions, we can have multiple interfaces. And then each feature module would be able to provide the relevant implementation, where the nice thing is that we wouldn't need to use the string literals anymore for the qualified class names, which makes it a bit less fragile. But it's a bit more work, and I'm not sure it's worth it. The other part that we had to consider was design systems. Does anyone use a design system here? So, I saw a few hands. So, a design system is something that the designers use to be able to define a set of components for a design language. So the idea is that you'll be able to define a type of button or different types of buttons with different styles, and anywhere in the app you'll be able to use that you want to use a button. You can say, I want this button with this style, and if that's the use case for the button, then it's going to look the same everywhere in the app. The reason that this comes about is because it's one of the more frustrating things to deal with in a large project is inconsistent designs, because you get new designers onboarded, they're working in their individual feature teams, and they're coming up with their own ideas to resolve the same problems. The design team I work with uses libraries of symbols in this app called Sketch, and the intention is that all the designers can build screens with a consistent look and feel. So the symbols here are configurable, so they drag and drop them into their artboards, and they can use them as templates, but still customize the content so it's clear what the context is that they're used in. And it's really rare for them to contain any information about the domain. This is a great candidate for a library module, so for symbols that are used in multiple feature modules. The model that we're going to use here is domain agnostic, so it isn't coupled to any of the features. So in this library module, we're going to define a view for a list item, and it's going to have an optional poster, so there might be places where we don't want to display an image. It's going to have a title, and it's going to have the click listener as well. And the nice thing is that any changes to the design can be made in a single place and updated throughout the app. Hopefully, changes to this module would stabilize over time. So at the beginning, you're going to make lots of changes. You're going to be adding new symbols to your library relatively frequently, but the idea is that over time you're going to have a consistent design, and you're going to be using stuff from that library more than you are adding stuff to that library. And the idea is that you want to minimize changes to these root modules because they're going to trigger our whole app to recompile.
Cool, yeah. So as well as a topic of design systems which affects our whole application, we also had to start to think about dependency resolution, which was a topic we were quite looking forward to exploring because when it comes to dependency injection on applications, especially in multi-module applications with dynamic feature module, there's been a lot of questions from the community. So we decided to take a look at both Koin and Dagger for our dependency resolution, just to see the differences between the two when it came to our application. One thing we quickly learned was that Dagger Android does not work with dynamic feature modules. So where we usually just call Android injection.inject, this does not work with dynamic feature modules currently. So we had to explore just using core Dagger for this setup. So let's take a quick look at how we approached the structure in each framework. So for both dependency resolution approaches, we ended up with pretty much a similar approach. Like, to be honest, there wasn't much difference between the two. We take the example of a use case class with an application, and we can see how this kind of setup looks. So this get themed details use case class lives within our domain module. This module also defines a repository interface, which defines the operations which are used by regarding the film detail feature. So now when we make use of this use case class somewhere within our app, an implementation of this repository is going to be provided. This implementation is defined within the data module of our app. So the data module knows about the domain module, but the domain module knows nothing about the data module. So for the reason, the data module is going to define a Koin or Dagger module, which will handle how that implementation is going to be injected wherever it is required. So in our domain module, we have this defined use case class, which takes its repository as a constructor argument, It uses the inject constructor if we're making use of Dagger, and with Koin, we didn't need this. We'll then have this implementation of the repository defined inside of the data module. So one thing to point here is that the implementation can remain as an internal scope with Kotlin because no outside module needs to be aware of this implementation detail from the repository.
So with Koin, the first thing we need to do is create a Koin module. So as Joe said, this is declared in the data module. The Koin module itself is public, so it can contribute to the overall graph. You can see that we're specifying the return type as film detail repository. So this is the interface that's from the domain. The implementation, Android film detail repository, is internal to the data module and isn't exposed. In our activity or fragment, we load all of the Koin modules that we need for that feature. And as long as there's a definition for anything that we want to request in one of those Koin modules, we're covered. For Dagger, the work is pretty similar. So we create a Dagger module instead of a Koin module. The provides function specifies the interface as the return type, so then the implementation can still remain internal to the data module. And similarly, we can use a combination of Dagger modules from different parts of our app to satisfy dependencies that we need for the feature.
Once we had finished building the core parts of our app, there was a few parts that we previously mentioned that were quite overkill, and there was a lot more code and modules than we were hoped for. So one thing that we previously mentioned is the model mapping, and I think this is quite an important thing to point out because when it comes to defining those models in each of our layers, it can seem like quite a lot of boilerplates creating an application. So where we have the standard setup for our CLI modules as such, we can often end up with something that looks like this. But it's important to remember that you don't necessarily need this if the models do not change as you move through your layers. So we can remove those mappers, we can remove those models, and just define the models where things change. So, for example, we noticed that our API models in the remote layer have our retrofit annotations and so on, so we decided to have a model there. We decided to have a model in our domain layer, which is kind of like our core business model, and finally a model within our UI layer, which uses the parsable implementation. We then also decided to try and cut down our modules a bit because obviously as our features grew, we kind of started to get quite a few modules and it kind of got a bit hard to navigate in some cases. So what we can do here is we can reduce the modules where they may not be, again, needed so much. So in some domain modules, we may only have, say, one use case class or a couple of data modules. It can be possible to merge these into the same module. Again, this may be breaking that separation of concerns, but if it makes things easier to navigate and understand for your developers, then that trade-off can sometimes be worth that. We also decided to merge some of the modules together, which were used across features. So, for example, the remote modules were a great use case for this. So, whilst in some cases, it may make sense for each feature layer to have its own remote module. We decided to create a letterboxed API module, which kind of acted like an SDK. So that SDK contained everything to do with the remote operations, and then each module could use that as it required. And again, that would kind of be dependent on the feature you're building and the application you're working on. But for us, in this use case, it seemed to work well. So that's kind of it from our side for this project and what we've learned so far. The project is completely open source, and you can check it out on that GitHub link there. We're going to be continuing working on that with modularization, and so if you want to follow along, please do, and feel free to help us out with it if you want to. There's a few things we want to explore, which we haven't looked too much into yet, so if there's anyone who knows anything about this stuff, we'd love to have conversations. We're going to start looking into conditional UI based on dynamic feature modules, so being able to, I don't know, for example, show a play movie button if we have a certain dynamic feature module installed, which contains the logic for that movie. Loading content from dynamic feature modules, so accessing content from a dynamic feature module from within a base module. And we also want to explore multiple databases, which seems like a popular topic right now. Currently, we have a shared database throughout the application, but I think our goal for this is to have a single database per feature module. So maybe we'll have a database for the films, a database for the actors, and so on. And like I said, these are things we're exploring and we're going to continue working on and treat this as a playground. But if anyone's got any questions about this or about modularization or so on, we'd love to take a few minutes to answer anything that you may have. Let me know questions.